All right, now for an example, using a non-ideal mixture. So we have a mixture of 75% hydrogen, the balance N2, and that's stored in a tank at 800 atmosphere and negative 70 degrees Celsius. And we want to estimate the specific volume of the mixture in liters per mole. So first, let's start with hydrogen and its critical properties. So for hydrogen, critical temperature is 33 Kelvin, and then we also need to apply the Newton's correction by adding 8, since we applied the Newton's correction for hydrogen or helium. We're currently working with hydrogen. And then the critical pressure is 12.8 atm plus 8. So that gives us 41 Kelvin and then 20.8 atm. And that is because we applied Newton's equations. And then for nitrogen, the critical temperature is 126.2 Kelvin. The critical pressure is 33.5 atm. And then we are going to apply K's rule for a real gas mixture to estimate the critical temperature and critical pressure of the mixture. So T-C is going to be equal to the mole fraction of hydrogen, which is 0.75, times hydrogen's critical temperature, which is 41 Kelvin, plus 0.25, which is the mole fraction of nitrogen, times 126.2 Kelvin, and that gives us a critical temperature of 62.3 Kelvin. Now for the critical pressure, again 0.75 times 20.8 atm plus 0.25 times 33.5 atm, and that gives us 24 atm as the critical pressure. Now we want to get our reduced temperature and our reduced pressure. So our T reduced is going to be 203, which is that's just negative 70 plus 273 to convert to Kelvin, 203 Kelvin over critical temperature, which is 62.3 Kelvin, and we get that is 3.26. Now our reduced pressure is going to be 800 atm over 24 atm. And that ends up being 33.3. So using this reduced pressure and reduced temperature, we end up getting, so from figure 5.4-4, we use TR and PR to get that Z is equal to 1.86. So we have a compressibility factor of 1.86. And that just really expresses how far away we are from an ideal gas. So if Z was 1, this would be an ideal system, but Z is not 1, so that just expresses how far away from ideal we are. It's like the variation from 1. So we can get V as being ZRT over P, and that's going to be So we have a Z of 1.86. And then we have an R of 0.08206. Our temperature is 203 Kelvin. And our pressure is 800 ATM. And so that ends up giving us that we have 0.03874 liters per mole. And that is the specific volume of the mixture.